we'll see the deviation of gases from ideal behavior or the nature of real gases. So we can see a same gas in different temperatures existing or showing different deviations. This straight line shows the ideal gas. That is, if you plot PV by nRT by to the pressure, we'll get a straight line. That is ideal gas behavior. But in the case of different temperature, we can see they are deviating this much deviation from this ideal behavior. This violet color showing this much deviation in 173 Kelvin. So you can see in each temperature it is varying from ideal behavior. So we'll see what's happening here. So real gases do not obey ideal gas equation or at all conditions of temperature and pressure. So if we see this graph that we have seen already, if you are plotting PV versus pressure, that is pressure into volume versus pressure, we'll get a graph like this. For ideal gases, PV is constant for any pressure. Any pressure it will be constant. But a straight line, this is the ideal gas graph. But in the case of hydrogen and helium, PV increases with pressure. If pressure increases, pressure into volume will be also increases. But in the case of carbon monoxide, methane and all, first the PV decreases, then reaches minimum value, then it increases. So such observations are identified by scientists while doing the experiments practically. We know this ideal gas is a theoretic concept. But in the case of an experimental concept, scientists were observed these type of deviations. Why this deviation is happening? The reasons are, it is the wrong assumption of kinetic theory of gases. Based on kinetic theory of gases, we have seen the assumption that the actual volume of the molecule is negligible compared to the volume of the gas. There we have seen that because in gas particles or gas substance, there will be large volume because the gap between two atoms or ions will be more. So the volume also large. So considering the distance between two molecules, the volume of one molecule considered as negligible. This is one of the assumption of kinetic molecular theory. Then the next assumption is there is no force of attraction between the gas particles. But these two assumptions are wrong in the case of high pressure and low temperature. If we take high pressure, if we applying high pressure on a gas, the volume will not be negligible and their atoms will come closer. So there should be a force of attraction in high pressure. In the case of low temperature also similar condition will arise. So these two assumptions we cannot consider it as true. So these are wrong. So only two cases real gases obeys ideal equation, that are at very low pressure and high temperature. So real gases deviate from ideal behavior at high pressure and low temperature. So there is a correction. So we know as per ideal gas law, there is an equation is PV is equal to nRT that we have derived already. So but we cannot take it as correct. So the Van der Waals proposed an equation which is applicable to real gases, that is P plus n square A by V square is into V minus NB is equal to nRT. We'll see what are the terms here. Don't worry seeing this big equation. You need not to study all the derivation and all. We'll go to the simple ideas. Wherein P is the pressure of the gas, V is the volume, R is the universal gas constant. These all we have seen in our PV is equal to nRT and the ideal gas equation. N is number of moles. This all you know. Then what is A, B and all? This A and B are Van der Waals constant. This n square A by V square, it is a It is the pressure correction. This term is pressure correction. We know in the case of real gases, there will be correction in the pressure, and this NB is volume correction. So P plus, so high, we know it is in the high pressure and low temperature, low volume. So P plus N square A by V square is pressure correction, and this is the volume correction. These are the van der Waals equation. So what is the signification of van der Waals constants? A is the measure of the magnitude of intermolecular attractive force within the gas, and B is related to the volume of the particles. These are the correction terms added by van der Waals. So you have to study only an elementary idea of these things. Okay, thank you.